So the third and fourth question, they are of this, very weird variety where you just have to plug in a number of values and then see what the answer is, right? That's how you would do it, given the information you already know. But now, of course, I'm a different case, right? I'm a complete idiot. I just searched the whole internet, saw if there's any method out there that can actually effectively solve these kind of questions. And well, sad to say, I didn't find any good method. I did find some methods that are slightly more effective than just using the rational root theorem. So a more effective rational root theorem, which is basically like, okay, you got this kind of weird polynomial function. First of all, you will do a series of transformations that will transform this into a simpler equation with which is a monic polynomial, right? That kind of equation, right? And only having integer coefficients. So what that would do is that it will completely convert all our rational roots into integer roots, right? So there won't be any non-integer rational roots. There will be all integer roots. And then after you have that, you will just start plugging in values without seeing whether or not those actually satisfy the criteria for rational root theorem. You will just start plugging in values. You will, yeah, basically you will try to find the zero, but we only have to figure out between what integers this, polynomial changes sign, right? So at what values does this polynomial almost go to zero, right? So it becomes a very small value. And then once you know that polynomial, you will shift the whole graph. Sorry, once you know that value, that x value, you will shift the whole graph by another transformation for this equation, right? To that number. So say at 2, I don't know, just giving an example, at x equal to 2, that polynomial turns out to be 1, right? So 1 is a very small number in comparison to what you would get after the formation of the integer root polynomial, right? You will have some constant value, right, after that formation of the integer root polynomial, and most likely that that constant value will be very big. Yeah, so we don't want that big a constant value, because once again, that's just a lot of cases if you want to use a rational root theorem after that. So what we want to do is change the constant of our equation to something that is smaller, right? So we'll just start plugging in values and see if for some value you will get a value of the polynomial that is a small number, and then you will shift this graph to that number, right? So what you will do is just replace x by x minus whatever number you got, right? Whatever x value you got, right? Do that thing. And yeah, that's very obvious that whatever, yeah, okay. Do I really have to tell this? Yeah, instead of x, you want to go to x minus something. So actually you should, change x from, okay, you should replace x by x plus that thing. Yeah, that's what you should do. Right, because we want to see around that number, where do we get a 0 or something like that, right? So to do that, yeah, you should do that. Make sense, right? So it's not me that came up with this whole step-by-step method. Instead, I got parts of it from Stack Exchange, from some other sites. Yeah, I even got an alternative method where you actually factorize a biquadratic into two quadratics. So that's usable when you don't have any rational roots in the first place. So maybe the only factorization that you could do is something like that, or maybe, yeah, that's the way. So into two quadratics which are not reducible, right? But yeah, let's not do that, because that is just, I don't know. I don't think it will always work, because what if you got an irreducible cubic and a linear term, right? So that forming this biquadratic, then that's a problem, because you can't actually factorize it into two quadratics. So I guess the first method, the modified rational root theorem, that's much better, right? So I mean, it is rational root theorem, but with a lot of other stuff thrown in, so very algorithmic, right? Okay, so let's try to figure out how do we solve the third question? So first thing you see is that you got 6 over here and negative 4 over here. Which of them is smaller? Of course, 4, right? So what we'll do is we'll shift, we'll make a transformation for this equation. So what we'll do is replace x by 1 upon x. So what I'm saying is you got this polynomial 6x power, okay, this equation 6x power 4 plus x cubed minus 2x squared. Oops, it's 3x squared minus 3x squared minus 9x minus 4 equal to 0, right? So what I'm saying is multiply this whole thing by 1 upon x power 4, and in fact you also want to make this positive, this coefficient positive, so multiply by a negative as well, right? So this whole equation, in fact, so what that will do is just do 4 times 1 upon x to the power of 4, then plus 9 times 1 upon x to the power of 3, cool, and then plus 3 times 1 upon x squared, then it's going to be negative because that was negative, so negative 1 upon x, and then finally negative 6. Okay, next we want to get rid of this 4. So the way we'll do that is we'll just set 1 upon x to be equal to something like u upon 4, right? Such that, you will get rid of that 4. Okay, you will have 4 cubed in the denominator and everything, but that we can just multiply out and it will become a good equation. So you will see why I'm doing this thing when I actually figure out the equation. So doing this, right, what do you get? Just get like 4u power 4 upon 4 power 4 plus 9u cube upon 4 cubed. That's just going to be 4 cubed, isn't it? Yeah. Plus 3u square upon 4 squared minus u upon 4 minus 6 is equal to 0. So now multiply this thing by 4 cubed. So just get u power 4 plus 9u cubed. Is that right? It should be 9u cubed. Yes. Then you got 4 times 3 is like 12, 12u squared, and minus, now you got 4 squared, so minus 16u, and finally minus 6 times of 4 cubed, so 6 times 64, right? So you got 4 to carry on 36 is like 384, so minus 384. So this is what I was talking about. This is a very big constant. You don't want a constant that big. So first thing, what we'll do is, figure out the range in which we have to look. So what is it at 0? At 0 it's just negative 384, and we know that as you go forward after some point this just becomes an increasing function. But let's reduce that stuff and just figure out till what range you have to look. So right, what about let's just put in 10, so if you put 10 you will get 10 power 4 plus 9 and then all that stuff, right? This thing is much bigger than this thing. Makes sense? When you put 10 in there. So you only have to look between 1 and 10, right? So the reason I'm doing this is, okay, if you got something like, instead of having this as the constant, you got negative 38400 or something like that. So now it's a, 1, 2, 3, 4, 5 digit number. So in that case, 10 wouldn't work because this is like just a 4 digit number, right? It's a 5 digit number, of course, but you got like, 100 and all that stuff. So that's the biggest it can get, and then 9u cube and whatever, right? It cannot match up with this thing, right? So oh wait, it's a 4 digit, then it's just gonna be till here. Oh, it really does not match up in that case. Right now it is matching up because these are comparable, right? They are their sizes are almost same. Okay, I'm saying almost, it's not like that. You get the idea, right? From a 3 digit to a 4 to the smallest 4 digit number, it's not a big leap. But from this thing to that thing, it is a big leap, right? How in the world am I going to get something like this from combination of these guys? No way, right? So that's why I did this little range stuff. So to understand in what range do we have to look, right? And if the range is too big, just figure out like what your step should be for different values, right? Okay, so once that's, and most likely you will never get a range that is too big because then it's not solvable in the first place. How am I going to solve something that just has too big a stuff going on? Okay, I'll get to that later. First, let's solve this thing. So now we know you just have to look between 0 and 10. because at 10 I'm guessing it's going to be positive, right? You just got like 19,000 and then you got 1200. So yeah, it's going to be 20200 something like that. Then minus 16u is like, okay, minus 160 and all that stuff. So 384 minus, okay, and then you got 160, right? So 4 4 is 4, 1 carried on 2, and then you got this thing, so 544, right? That's what it's like. So yeah, that's positive, which means you only have to look between 0 and 10. So let's start putting in values. At 0, no, it's not changing to a smaller value. At 1, you will just have 1 plus 9 plus 12 minus 16 minus, okay, that's not even comparable to that, so no major change in that. What about 2? So 2 power 4 is 16 plus 9 times 8, that's 72, plus 12 times 4 is 48, minus 16u, so minus 32 and minus 34, right? Okay, let's combine these. Maybe it's gonna turn out to be something smaller, but who knows. Okay, this thing is gonna be just 40, and this stuff is going to be like, okay, 5 6, okay, 6 4 6 4, and this thing is only 104 minus 384. Yeah, it is smaller, but not the kind of small that we are looking for. So it's 280, I get it, it's smaller than this thing, sure, but still not small enough. We just keep on moving. After some point we know it's going to be not negative anymore, and it will start becoming positive. Yeah, because x power 4, right? It has to become positive in the end when we go to infinity. So we'll just wait till that happens. And yeah, okay, let's put 3 in there. So when you put 3, what do you get? So you get 3 power 4, which is just 81, plus 9 times of 27, which is 243. Yeah. Wait, something's wrong. No, 18 and 63. That's 243 for sure. Okay, plus 12 times what? 9. So it's 108. Minus 16 times 3, which is minus 48, and then minus 384. Is this small? So combine these out. 8 1 9 9 3 2, 1 carried on, 5 8 3, 1 carried on, 2 2 4, nothing. So 4 3 2 minus, what is this going to be? So 2 1 carried on, 5 3 1 carried on, 4. Hey, wow, that was fast. So we got a root. Huh. This turns out to be 0. Okay, this was unexpected. So what I thought was that I will get something small, but whatever. We got a 0. That's much better than getting something small, right? No need for that transformation anymore. Right. So now that we have this thing, yeah, this is equal to 0. What does that mean? U equal to 3 is a root for this equation. So just factorize this using u minus 3 as our divisor. There we go. Let's figure this out. U power 4 plus 9u cubed plus 12u squared minus 16u minus 384. Okay, let's start. So u cubed, got u power 4 minus 3u cubed. Subtract that. What do you get? You get 12u cubed. Okay, then plus 12u squared. So we got this thing, and then 12u cube. Okay, yeah, minus 36u squared. I guess subtract that. What do you get? 48u squared minus 16u. Just have to do this thing, plus 48u. So you got 48u squared minus, got 12 and 24 is just 144, right? Of course, this is unexpectedly big. Subtract this out. Okay, did we do that correctly? Of course we did that correctly. No doubting now. So 144 minus 16, I guess, which is, so 14 plus 8, and then you got 3 minus 1 is 2, so 128u, and then you got this thing minus 384. So I'm guessing it's just going to be plus 128, and this is, okay, this times 3, so 36, and then you got 24, which is 384. Come on, that works out perfectly. So there we go. That's the next thing that we got. U equal to 3, and then you got this thing. Okay, so u equal to 3, or this thing is equal to 0. Once again, we turn out to the same strategy once more. At 0 it's 128. We want to make this small. Okay, we have to go the opposite way now, so we'll start off at negative 10. At negative 10 it's got like negative 1000, negative 1200, negative 40. Okay, that's sufficient. It's much bigger in magnitude than these things, so we have to look between 0 and negative 10, right? Okay, and yeah, it's comparable to 120. Okay, it's not actually, but so maybe something smaller. What about 5? So negative 5 cubed, that's like 125. And then this is, oh wait, okay, that was weird. When you put negative over there, it should just be negative 1000, and then you got plus 1200. But yeah, it's still much bigger than that, so no need. Okay, so then the thing we should go to is negative 5 maybe. Okay, who am I kidding? Just start putting in values. We'll see what happens. So at 0 it doesn't work. What about negative 1? No, it won't work. Too small. What about 2? Maybe it will work. Who knows? Like minus 8. I don't get how it's gonna work out. Yeah. Okay, just got like plus 12 times what? 4. That's 48 minus 48 times 2, which is just 48 times 2, because that's gonna be 48 combined, right? So it's got negative 48. That's just too small. 3, 3 cube is 27 plus, oh, it should be negative. And then 12 times 3 squared, so got like 9, and I don't think it's gonna be good. Okay, what about this guy? 3 times that's just 12, and 24 is 144. And yeah, okay, we got 128, and this guy, so 12 times of 9, I guess that's gonna be 108. Yep, that's 20 something. It doesn't match up. So 4, that's the next best thing. So 4 cubed, that's gonna be 64 right there. Then, okay, 4 squared is just 16. Just first of all do that, guys. Minus 16 and 32 is just 192. Right. Plus 128. And then 12 times 4 squared, like 12 times 16, I guess. Yeah, so 12 times 16. That is 6 and 12 is just 72, and then we got 0, 1, 2, we got 192. Okay. That is almost, oh sorry, that's 190, not wait, that was 190. Why did I write 129? Supposed to be 192, right? Oh, so this actually turns out to be making sense, huh? Yeah, at 4, of course. I mean, this is just 4 times of that. That is why it happened. So hey, that looks small actually. Yeah, so I'm guessing at 5 you will get another root, or you will get something that's positive. Oh sorry, something that's negative, right? If that happens, we can just say u minus 4 and do the thing. Okay, yeah, u minus 4 equal to v, or u equal to 4 plus v. Right, first of all, just deal with this. So you got 128 minus 64. Did I do this incorrectly or something? No, how could I have done that? Well, that cancelled. Then you got 128. Sure, it's just gonna be 64. Perfect. And yeah, that's the way it should be. Okay, and then you have to go for 5. So 5 is just 125 negative. And then you got, wait a second. Okay, 5 cannot be a 0, unfortunately, because that's not a factor of this guy. We already know that. So what does that mean? That means you have to shift to u minus 4 now. Right. So we'll just say u is equal to v plus 4, and factorize this somehow. Okay, so v plus 4, what's u cube in that case? It's gonna be v cube plus 12v squared plus, okay, come on. What am I doing? It's negative 4, not, yeah, you have to go for negative 4. So we'll just say u is equal to negative, I mean, this is still not, yeah, I mean, how did this actually work? 122 64, not a very big change actually. I mean, that's just 2 times of, yeah, the number of factors is not that different actually. Although it would be better if I actually do this thing, because who knows, it might just simplify a lot. So maybe worth doing, who knows. Some other method. Just 3 times of, hey. Actually, it's much easier than that. Okay, so You don't have to do each term separately, just do this thing. U cubed and then plus 3 times of 4 times of u squared plus 3 times of 16 times u. That of course works. And then you just need what, 4 cube, that's 64, but that is remaining, so that's what I think. And oh, this just turns out to be, oh god, that's just awesome. Yeah, so u plus 4 is equal to -4. That's the only way out. Perfect. What does that mean? U is equal to -8. That's the only solution to this equation. Perfect, right? The real solution, that is. So what did we get? There's only two solutions, which was u equal to 3 or it's going to be -8. Cool. So, what was x, by the way? 1 upon x was equal to u upon 4. So x is just equal to 4 upon u. So it's going to be 4 upon 3 or it's 4 upon -8, which is -1 upon 2. So these are the only two roots of this equation, right? Yeah, this took so much work to be done. But at least this was more systematic than just, calculating everything for every single possible rational root you could get. That would have been a headache because then you have to like factorize and stuff. And yeah, that's just too much, isn't it? Right? Or maybe factorization was not needed. You could just, actually do this for every root. But it's got 14 different roots. Okay, possible roots, right? 14 different values that you get from the rational root theorem. So how are you going to do that? 14 values. Do you understand the magnitude? And each of those has like multiple calculations in themselves because you got how many terms? 1, 2, 3, 4, 5 already. So you at least need 5 terms in each calculation, and then you got x power 4 and whatnot. Yeah, that would be just be a nightmare, isn't it? Unless of course you got lucky and just figured out that -1 upon 2 is a root, and then yeah, it would be easy. But okay, maybe I'm exaggerating. It's just 7 roots actually, because the negative version of the roots, you just have to switch signs, and then once again you have to calculate a bit, but not that hard, right? For the negative version, once you know for the positive version, but still you actually have to go for at least 7 roots. So that's something, yeah. Okay, let's go to the fourth question then. Hopefully this will be, a similar kind of question, and I don't have to once again go into that mode of looking through the whole internet to figure out something that works. I mean, actually works, instead of just making me work harder. Actually is a proper way of solving this, right? Find the rational roots of this thing. So once again, each of them is smaller. I think 2 is smaller. So we'll just first of all do x replaced by 1 upon u. So we just x is equal to 1 upon u. Then it's going to be just, or first of all, don't do that. Yeah, just write the usual way. 1 upon x power 4 plus 35 times 1 upon x cubed and all that stuff, right? And then you indeed have to get rid of this 2. So we'll just say 1 upon x is equal to u upon 2, right? So basically x is equal to 2 upon u. That's the equation that you should be dealing with, right? Okay. So now what do you get? You get 2 times of u power 4 upon 2 power 4, then plus 35 times u power 3 upon 2 power 3. But I'm thinking maybe I should put -2 upon u because it's all positive, so there's only going to be negative roots for this thing. But yeah, whatever. Maybe we should, we should. Yes, we should actually, because you definitely don't want more complications. So this is what it should be like. You got negative over there, whatever. And what else? 62 over there. Okay, we got positive 62 u squared upon 2 squared. Okay. Then you got -35 u upon 2 basically. Isn't that how it should be? Yuck. And then plus 6, right? And then you have to reduce this a bit. So you got 2 cube and whatever. This thing can be thought of as 31, and then Oh, we don't even care because we're going to multiply by 2 power 3 anyway. So it's u power 4 minus 35 u cubed. Then you got 2 cube upon 2 is just 2. So plus 1, 2, 4 u squared. That's 35 times 2 power what? 2. So 35 times 4, which is 12, and 20 is like 140. So minus 140 u, and then plus 6 times 2 power 3, which is, okay, that's easier actually. So that's the thing. Hey, you know what? This is actually already very small, right? It's just 16 times 3. Okay, 2 power 4 times 3. No, it's not small. Ah, but what hope do we have? Because like this, it's gonna be complicated. Well, you could try putting 1. Maybe 1 is a solution for most. Like 1 minus 35 plus 124 minus 140, and then you got plus 48. So this whole thing, or you may just negative 1 0 0, and you got plus 8 over there. Yeah. Okay. So that's gonna be just 24, 24, and 8. That is 32. Wait, what? Oh, that was not good. So it's minus 2. I get it. That's a good transformation, but seriously, that's not nice. Hey, how did that even happen in the first place? Right, something's wrong, Bombs. That's 24, and that's 8. That's uh 32. Sure. That is 33, and that's negative. Of course, it's negative 2. There's no other way. So what do we do? Yeah, like 1 is a good thing. What about 2? Maybe 2 will be even better. So it's 2 power 4 and all that stuff. Hey, but yeah, putting u equal to 2 is pretty much as putting, you know, it's equal to negative 1 or something like that. Okay, x equal to negative 1 in the original one. Does that work out? I don't know if it's better or worse, but who cares? It's got 6 minus 35. Okay, plus 62 minus 35 once again, and then plus 2. Is this going to work out? That's like minus 70, and then you got, that's 8. Oh wow, that was very quick. So yeah, turns out u equal to uh, 2 does work, in fact. So now what should we do? Should we actually look for this guy and then factorize that, or should we factorize this thing? I would say factorize this thing, because the cubic you will get will also be monic, which is a good thing. So there we go. Without even having to resort to transformations, you already got the root. That is a nice thing actually. Perfect, isn't it? Yeah. So there we go. U minus 2. So you could divide this by that. So you got u power 4 minus 35 u cube plus 124 u squared minus 140 u plus 48, whatever. Let's start. So u cubed, you got u power 4 minus 2 u cubed. Subtract that out, just get negative 33 u cubed, then negative 33 u squared. Okay, so negative 33 u cubed, and then you got, what's this thing, minus 2. Minus 2 times that is just plus 66 u squared. Subtract that out. Okay, so that's 8, and then you got 11 minus 5, 58 u squared minus 140 u. Okay, cool. So consider 58. So plus 58 u. So 58 u squared, and then 2 times, right? It's minus 2 times. So 116 u. Subtract that out. It's gonna be just negative. It's 4, and then what's just 2, 24, and then plus 48. Cool. So minus 24. See, this is much better than what you would have got if you actually went for this thing, and it would also be harder because you already got a 6 and stuff. And yeah, so that's what you get. Sure. So you know, u minus 2. Okay, so u can be 2, or we'll figure out what that should be when you solve this thing. So u cube minus 33 u squared plus 58 u minus 24, right? You want to make that equal to 0. Any obvious solutions for this guy? Nope, because okay, we check for 1, we check for 2. At 2 it's 0, and at 1 it was what? At 1 it was negative, right? So next is going to be positive at 3, right? Of course. Okay, but still, just keep on checking. Who knows, maybe it's just a repeated root at 1, right? So yeah, at 1 we just get like 1 minus 33. plus 58 minus 24. So that's like, okay, 59 minus 57, that's 2, so it's positive. At 0 it's negative, so it's between 0 and 1 that you would have a root. So what do? We just say u is equal to okay, 1 was the thing, right? So we just say it's equal to 1 plus v. That should be doing it. Isn't that correct? Hopefully it will do the thing. Okay, so just put that in there. What's u cubed? That's just gonna be like 1 plus 3. Okay, you know what? V cubed plus 3v squared plus 3v plus 1. Then this thing that like v squared minus 33v squared. Minus 33v squared. Then you got 2v that times minus 30 is like minus 66v minus 33. Okay, 58 times u, that is 1 plus v, so minus 58v. No, it's plus, sorry. So 58v, and then you got plus 1, so yeah, okay, plus 58, and then minus 2 like that. We know what the constant is going to be, but I'm just showing for, okay. And now you got minus 30v squared, and what's this going to be? So you got 61, so it's got like minus 5v. Okay, and that cancels, I guess. Minus negative 1 is 34. Well, that didn't work out the way I thought it would. Did I mess up somewhere? That's 58 right there, and then what? That's weird. Hey, where did 24? Oh, okay, that 24 is also there. You should take that into account as well. So this is not minus 2, it's minus 24. Oops. Okay, now we are good to go. And in the end, what you get? You say 2, right? So this whole thing should be 2. Let's just figure that out once again. 59 minus 57, 2, of course. And now what? Just rational root theorem or integer root theorem, whatever you try to call it. So either 1 or 2. Hey, if that was that easy, you would just have, oh yeah, no need for doing it. Fine, just keep on going, we'll get somewhere. So it's already, okay, 1 plus v. We already checked for 0 doesn't work. Also this is a constant, and right, so minus 1 won't work. What about minus 2? Did we check for negative 1? So negative 1, that's like probably not going to work, but whatever. Negative 33, then negative, that doesn't work. So the only next thing that we can do is check for u equal to 2 or v equal to 1. Both are the same things. We've got 1 minus 30 minus 5 plus 2, and that doesn't work. What about negative 2? Yeah, don't count on it. It's going to be negative, of course. Yeah, that. And was negative 1 working? No, it doesn't work like that. So what can we conclude? This has no rational roots. Oh yeah, interesting. So the only rational root is when you have u is equal to 2 and x equal to 1. Sorry, okay, negative 1. That is the only rational root for this thing. Wow, that was not good. Don't we actually like get 2 rational? No, we don't get 2 rational roots. This is very weird. But I thought we would get 2 rational roots. For some reason, we are not getting 2 rational roots. Why? Why am I not getting 2 rational roots? Clearly, negative values don't work over here, because when you put negative, like this will be negative, that will be negative, it won't work. But okay, positive values. We tried out 0, we tried 1. 1 doesn't work. That gives us 2. What about 2? Probably it's going to give us something even more positive, because negative then positive, then once again positive, right? Okay. So, hey, what's the derivative of, oh yeah. What's the derivative of this thing? It's 3u squared minus 66u plus, I'm just guessing that it might just be an increasing function, who knows? Because then it's going to have only one root, which is between 0 and 1. 0 and 1, between them there's no integer roots, and this can only have an integer root because rational root theorem. So that would conclude that there is actually no root. And reduce that, this is u squared minus 22u, and then plus, what's this thing? Is that 50? I guess, yeah, that's 58, of course. So Oops, wait, what? No, 29, sorry. Right, so like minus 11 squared. It's got negative numbers. No, the discriminant is not negative. Discriminant is not positive. Yeah, the thing is, it's not increasing. Okay, all that is good, but it still does not have any rational roots because we checked everything and nothing seems to be working out. So that concludes the thing, right? Yeah. Did we do the transformation correctly? I guess we did. Yeah, don't see what could have gone wrong over here. So it's v cubed, then minus 30 v square, and then this thing, so 61 and then it's 5v, whatever, and plus 2, right? So it only has, yeah, like that thing gave us 2. Actually, you know what? I could have stepped this whole step of transformation. Just looking at 2, you would have guessed that the root of whatever thing you would get, right? So the v value that you would get is a factor of this thing. So it's like u is equal to 1 plus a factor of 2. So it's plus 1 or minus 1, plus 2 or minus 2. And you just have to check those values, right? So actually it can just be made very much effective without even this transformation. But yeah, that transformation just adds more simplicity because you actually have another way of calculating, which is, I guess, easier than that. Debatable. Well, whatever. That's the thing, right? Okay, what does that mean? There's only one rational root, that is u equal to 2. So x equal to negative 1. Interesting. Or maybe I missed something. I don't know. If you guys find another root, comment, because I don't know if there is another root or not. Rational root, right? Okay. Oh, it's fifth question, not the sixth question. Given that the sum of two of the roots of this thing is 0, where a, b belongs to rational number, solve the equation for all values of a and b. Sum of two of the roots of this thing is 0. What? Other root will just be negative a in that case. Negative a upon 4, right? AB belong to rational numbers. Solve the equation for all. Oh, it's just like, okay, I see what's going on. Just put negative a upon b over there, right? Let's see what that turns out to be. So you got negative 4. Actually, it should be negative a upon 4, not a upon b, right? Negative a upon. Okay, negative a upon. Oh god, what am I doing? And what's this thing? It's negative 1, huh? Solve for the values of a and b. Okay, like alpha plus beta is equal to 0, and then you got this stuff is just alpha beta plus beta gamma plus alpha gamma. So alpha plus beta equal to 0. You can actually just, yeah, take gamma common, and like that's gonna be 0, so that's gone. Alpha times beta is, oh, you don't even have to ask me. Yeah, alpha beta is just equal to negative 1, and then alpha times beta is equal to, alpha plus beta equal to 0, right? Do you have any idea how much that simplifies it? It's just a quadratic kind of system, and then yeah, so alpha beta, it's 1 minus 1. That just, wow, that was so easy. They just, okay, that's awesome. So now we know it's 1 or minus 1, right? Okay, so yeah, cool. Let's figure out what gamma should be using this. Okay, that's unknown. Can't believe this. That's an unknown quantity. Why? Oh, and by the way, it's not actually negative 1. It's negative 1 upon 4. In that case, it's actually not, 1 and minus 1. It's actually 1 upon 2 and minus 1 upon 2, right? So we just say alpha is equal to 1 upon 2, beta is equal to negative 1 upon 2, gamma we do not know. But using gamma, we can express what a and b should be. So a is just alpha plus beta plus gamma, which is basically gamma. A upon 4, negative a upon 4, that's equal to gamma, right? So a is just equal to negative 4 gamma, and then for b, just got like negative b upon 4, that's equal to alpha times beta times gamma, which is negative 1 upon 4 times gamma. Make sense? Yeah. So b is just, is that right? It should be. And AB are rational numbers, but wow, that doesn't make any sense. I mean, it's gonna have a bunch of different ways that this could be, right? Gamma could be any kind of rational number, And yeah, that is bad. That's not good. Oh god. But okay, that's the way it is. It's just alpha beta gamma. That's negative upon 4, and that's still with this guy. So B really is just gamma. So B is gamma, in fact. Interesting. Right. Any other thing they gave us? No, they just gave us this and that, nothing else. And also the sum of the two roots is 0 and whatever. So there's only one way that this could be. You see? Yeah, okay. So there we go. You got the solution, although it's not exactly a solution because you don't know what A and B are. So all values of, yeah, just rational numbers, this equation is good enough. So A equal to negative 4B where A, B are, so like B is a rational number. Makes sense. Okay, that's all the information you can get from this. A equal to negative 4B. Yeah. And B can be any rational number. So the rational number is, okay, it's this thing, Q. Whatever. Next question. Are these going to be specific values? I don't think so. Next. So gamma is open, right? It could be anything. Find AB such that the roots of this thing are real and in GP. Okay, so these are in GP, then the product is just 8. The middle root must be 2. Yeah, so middle root must be 2, and these are also real. So it always has one real root, and for it to have three real roots, wait, you mean all values of A and B, and not even rational values, just all real values of A and B. That's not nice. How do we even know the other roots? We don't, unfortunately. Okay, one of the roots is 2. Other roots might just be 2 times r and 2 upon r. So you've got 2 times of 1 upon r plus 1 plus r. That thing is so the sum is just equal to what? Let that thing go, it's negative 8, right? And wow, that's weird. And then you got 2 times of the combined products. Oh, it's like 4 actually. So 4 times of 1 plus r, because yeah, and okay, that was 1, that was r, and now these guys just 1 upon r once again. That is equal to b, right? Oh, sorry, it's not. Yeah, it is b. Okay, cool. So just dividing this, get like negative b upon a is equal to 2. So b is just equal to negative 2a. I should be doing it. So b equal to negative 2a. A is any rational number. Okay, cool. Next. 7th. Show that 2x power 6 plus 12x power 5, blah, 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 whatever. Okay, this has no real roots. Once again, something that's awfully not doable right away. Okay. This has no real roots, you are saying. It is 2x power 6 plus 12x power 5 plus... No real roots. Wait. Are you serious? No real roots. Not even rational. Oh god, that's... That must be something else that we should use in that case. Okay. First thing first. Okay, no, that's gonna have like 2 power 6 and stuff going on. That's not something we should be doing. Something else. Maybe trying to factorize this without doing any crazy stuff. It's 45 over there. It's just, how many terms you got? One. Okay, you got 7 terms, right? That's already hard to factorize. Okay, think. So 30 and 80. You take a 10 out, it's 3 and 8. What about this guy? 12 and 30. No, nothing is matching up, unfortunately. But 2 and 45. Wow. This has no real roots. Clearly no positive roots. All the roots can only be negative. Okay. Come on, think about it. But x cube and whatnot. You can't just divide by x cube and try to form a symmetry. There's no symmetry in the first place. Right? So that won't work. Come on, think about it. What should we do over here? how do I prove this has no real roots? It's not even just, some kind of odd degree polynomial. I could just prove that it's completely increasing. You can't do the same thing over here, unfortunately. You can figure out the minimum value or something. So if it has no real roots, it should always lie above the x. So if you just like prove that its minimum value is actually positive, we are done basically, right? So maybe that's something. Oh, let's try it out. So how do you figure out the minimum value? Just take a derivative, equate it to 0. 12x power 5 plus, what's this, 60? X power 4 plus 120. I guess we are getting to something. Okay, plus 180 x power 2 plus, so we got what, 80x, like that's 160 x, and then plus 30, right? That's equal to 0, whatever. So all of these are just multiples of 6, first of all. So hey, are these all multiples of something? No, but these are, right? So all multiples of 6, I guess. So you can start reducing. 2x power 5 plus okay, right, and then plus, what about this guy? So 10x power 4 plus, but okay, all the minimum values should be more than 0, right? So you actually have to figure out all of these values, right? The roots that you will get. That's just so much of work, but yeah, keep on going. Hopefully something nice will happen. So 20x cubed plus 30x squared, right? Oh wait, okay, no, it's not 60 that we're doing. We're just doing, well, no, we were doing just 6, right? Wait, what about that 160? That's not even a multiple of, oh, that's bad. Okay, so that doesn't work out. What else can work out? 2 probably, because what else do we have? 2 is the way to go. Oh, come on, seriously. What if this has like only one real root? Like this equation only has one real root. That would make it a lot easier for us to figure out the minimum, right? So take another derivative. Who knows? So take another derivative. It's like what? 60x power 4 plus 240. Is that 60? Yeah, that's 60. 240x power. What was that? Short. Okay, 240x power 3 plus. This is getting very weird. Plus, okay, what is this thing? Part 360x squared plus 360, is that? Yeah, that's 360 x and plus just 160. So you can get rid of those zeros. All multiples of 6, no, but all multiples of 2, yes. So 3. Oh, it's still not working. Can't believe this. Okay, first of all, let's reduce this guy because, yeah. So it's gonna be what? 6x power 5 plus 30x. I hate this. Just hate this. Yeah. But keep on going. Get somewhere, hopefully. No other way of doing this? Are you serious? Can't believe this. There is no other way, huh? But how? How does that even... Did I make some mistake somewhere? No. No, I didn't. This has no real roots. Okay. Something to cancel out from everywhere. What if, instead of doing this thing, I just went, made x2 equal to 1 upon u and then took the derivative. So trying to prove that, yeah, okay. So if I change this and then took the derivative and stuff, something like that, right? We just have x cube over here. You will have x squared. You will have x cube over here as well. So, interesting. Some kind of stuff that I can do. Okay, that's gonna give us a factor of 3. That will also give us a factor of 3. And you got x cubed, so that has a factor of 2. So 6 can be cancelled out. I get that. I just don't like it the way it sounds. Come on, that's gonna be 90, right? Everything has a factor of 3, I guess. That has a factor of 3. That is a factor of 3. Well, it will be x cubed anyway, so it will actually have a factor of, oh, it will be x power 4, not x power. Okay, that's bad. That won't help. That just won't help. Okay. I guess this is the best thing that you can do. Just keep on going. Fine. Reduce this, and then you got this guy, 60x cubed. Hey, that was x power 4. What is this? Is this a torch? What? I don't get it. You have to do this thing. What other choice do we have? Is there any other way of proving that it actually has no real roots? I don't know. Maybe we can factor it into irreducible polynomials and then show that those don't have any roots. But that's such a far-fetched idea. It's a 6-degree polynomial. How am I even going to do that? Man, this is not helping. This is not helping at all. Even that kind of derivative doesn't work because we don't know if it's positive. Come on. Why? Why is this happening the way it is? Is this always increasing or not? Or what is going on? Okay, just keep on going. 60x cubed plus 90x squared plus 80x plus 15. I really have to take the derivative because I don't know. Must be something else. So, 12. Okay, it's like 30, sorry. 30x power 4. I mean, solving a biquadratic is much better than solving a pentaquadratic. Sorry. Solving a quintic. Yeah, that's called a quintic, right? Okay. 120x cubed plus, what's this, 180? 90x power 2. Assuming that I did everything correctly. Okay. 180x plus 80. Alright. So, time for some. Yeah, okay. That does it. All multiples of 3? Nope. Okay. Now we'll have to solve this thing. That's a bad idea. That means, okay, 8 and 3 are small, but not the kind of small I was hoping to get. You just have to put x is equal to u upon 3 in this thing to even get the values. Oh, that's not nice. What if this has no minimum values? Oh, it's all going. Yeah, okay. You have to show that the minimum values of these, right? Okay, the x values of these guys that we will get, right? So that the roots of this equation at those points, this has minimum value that is positive, right? That's what you have to show. So for that, you actually have to figure out the roots of this thing. No need for figuring out the derivatives, right? You just have to solve this equation in the end. So yeah, okay, now think, how do we solve this equation? It's already complicated, isn't it? Come on, think. Any special thing that I can do, something to factor it out without any kind of problem. It's like x power 5 plus 5 over there, and then you got 10. It doesn't help. That's 15, isn't it? How can that help? How many terms you got? 1, 2, 3, 4, 5, 6. Okay, maybe you can break it out into something. Rational root theorem. What other thing do we have? I don't even want to do u upon 6 and all that stuff because that's not going to help. It's going to make this very ugly and very big. Just gonna try putting something. So let's put -1. -1 is a factor of this thing, right? Okay, and okay, just try to do this thing. So -6 plus 30, -60, and you got -90. Oh, doesn't look good. Doesn't look good. Oh god. Oh, that was positive 19, not okay. Yeah, plus 15. Well, this thing is just 10. Okay. That doesn't help, right? What is this? It's like, okay, that's 10, this is -50, that's -20, that plus 50, that's -20. This is gone now because, right, and then that plus 15 is just 5. So it's gonna be -1. Very close. You know what? Yeah, let's do the thing. Let's say, okay, what's the factors of these? Of course. So instead of doing x is equal to what was the thing that we tried out? -1, right? -1 plus u, and doing the whole transformation, we'll just figure out the factors of this guy and put those. So what things can u be? It can be 1 or -1. Okay, not exactly, because you got the 6 over there. If it was like integers, it would have made perfect sense. So what can u be? U can be, okay, the factors of these guys like 1, 2, 3. So 1 upon 1, 1 upon 2, 1 upon 3. So it could just be, plus minus 1, plus minus 1 upon 2, or plus minus 1 upon 3. So that reduces it to 6 cases. Not nice. So just figure out what happens at 2 instead. So of course at 0 we know it's just not going to help. It's 15. But about at 2? So at 2, let's see what happens. 6 times 2 power 5. That's like 3 times of 2 power 6. Okay. What is this thing? 30 is just 15 times 2 times 2 power 4 is like 2 power 5. Okay. Plus, okay, 16 is like 15 times 4. So 15 times 2 power 2 times 2 power 3 is just 2 power 5. Hey, we have to actually go for negative 2, not positive 2. So it's supposed to be negative in this case, and that's supposed to be positive. Okay, minus 90 can be thought of as like 9 times 10, which is the 45 times 2. So 45 times 2 power 3. And then you got plus 80 times 2. Wait, something's going wrong. That was negative, this was. Oh, I mean, okay, just switch, make it negative, positive. We know it should actually be negative, then positive, and then negative, but whatever. And at negative 1, of course, we did the correct thing, should be negative 1. Cool. And just keep on going. We get to it somehow. So you got this thing. It was 1, 2, 3, 4. The 4 term, 1, 2, 3, 4, this guy, and then you got 2 more terms. Wow. It's just never ending, is it? So 80 times what? Negative 2, right? 80 is 5 times 16, so 5 times 2 power 4. So it's 5 times 2 power 5, and then negative, of course. And what else? Just 15. Sure. Some stuff cancels. Okay, that's 2 power 5. It's 2 cube, and yeah, not really helpful. You can write it as 6 times 2 power 5. So then this would just become negative 11 times 2 power 5. And that thing plus this guy, 45 times 2 power 3. You can, okay, just do the thing. Don't really care about 352 plus, 45 times 8. Right, that's 3. So, wow, 320 and then 40 is 360. It's taking so much of time. Okay, that also doesn't work out. Something like 375 minus 35. It's a positive quantity, so it went from negative to positive, which basically means that there's a root between negative 1 and negative 2, right? So, okay, you could just start putting negative 1 upon 2, and negative 1 and negative 1 upon 3. So now you just got 2 cases, and you just have to figure out whether these will work or not. And then you'll be good, right? Okay. Hopefully. Wait, where did the equation go? This is the equation that we're dealing with, right? Okay. Wait, but this already has a root? No, it doesn't. It doesn't. We just... Man, I'm only figuring out the rational roots. That's not nice. What if this has irrational roots? Then that's... Oh god. That's complicated. How do you even figure out the irrational roots? Oh god. Even calculus doesn't help in this case because we can't figure out the minimum values. Oh, it's not helping. What if we could, perfect, okay, write it as a perfect square of something and plus some kind of positive number. That would help, right? So maybe something to the power of 6, right? Okay, what if I reduce this by 2? Then you just got like x power 6. Maybe, I think that is what we should be doing because, depending on these, it's not a good idea, right? So x power 6 plus 6. Hey, I think that is what we should have done from the start itself. You got 15x power. Oh god. Seriously. And now I'm realizing this. Can't believe it. Okay. No, okay. This some right. It was good going till now, and now suddenly you have this thing. It doesn't go like that anymore. We'll figure it we'll figure it out somehow. Okay. 15x power 4, and then what's this thing? It's just 30x power 3 plus 40x square plus 15x plus 45.2. Now, yeah, okay. 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1, and then 1 6 15 20 15, 6, 1. Look, 1, 6, 15, but you just want a 15 from there. So we'll just say it's x plus 1 power 6, okay, but there are some terms that aren't supposed to be there, right? So you got like plus, so because that was just 20 over there, right? That's 15, that's matching. This is supposed to be 20, so they got 10x cubed. That is 15, that's supposed to be there, right? So plus 25x squared, I guess, right? And then that's plus, so 9. Yeah, 9x plus that's supposed to be 1. Just do minus 1 right there. It's gonna be 43 upon 2. Cool. So, okay, perfect. X plus 1 power 6 plus all of this stuff. So 10x cube plus, yeah, what that means is we should probably use x plus 1 as u. That will massively simplify everything, most likely. I don't know if that's correct thing to, okay, yeah, just do the thing, you know, let's just say x plus 1 is equal to, or x is equal to u minus 1. Yeah, and hopefully it will give something nice, right? Right? Ah, plus 1. I'm starting to think of something. Plus 1, huh? Hey, you know what? Okay, no need for doing that. First of all, let's, you know, simplify some stuff out. Not right now. We'll have to do a bit more of stuff. Okay, and you actually write this in decimal notation. So, to 1.5. Easier to deal with, right? Okay. So we can write this whole thing. Okay, what we would want is 10x cubed plus 30x squared plus 30x plus 10. We just want to extract that from here. So we just have x plus 1 cubed, sorry, x plus 1 power 6, and then x plus 1 cubed. Yeah, and that thing plus, so the remaining stuff. So that's matching up. What about this guy? Just have 5x squared. What about this guy? Oh, it should be negative 5x because you have to put that in there. So negative 5x. That's going to be negative. So 21x. Right. And that's 10. So just got plus 11.5. Everything. Much better than what we had previously. Isn't that right? So it's x plus 1 power 6 plus x plus 1 cubed. Now we can write this thing as, okay, you know what? Minus 5x squared minus 10x plus sorry, no, plus is supposed to be minus 5. Yeah, this is what we'll take out. So it will just be, you know, x plus 1 power 6 plus x plus 1 cube plus, okay, it's not plus. Oh, and by the way, it's supposed to be 10 times of that. So actually it's supposed to be 10 times x plus 1 cube. Yeah, that should be the better thing to do. So 10x plus 1 cube, and then you got minus 5 x plus 1 squared. But for that, you need this thing. So the other stuff should go somewhere. What will the other stuff be? It's gonna be just box that. So don't forget that it's not part of that. You got minus 11x and minus 5 supposed to be there. So you got plus 16.5. So, and now we can just use u. So u power 6 plus 10u cubed minus 5u squared. Now minus 11 and then x plus 1 is u, it's going to be u minus 1 plus 16.5 whatever. So u power 6 plus 10u cubed minus 5u squared minus 11u, and then you got plus 11 plus 6 plus 27.5, right? This is what we get. Cool. And now what? Well, yeah, we're stuck. Oh, I mean, this is much better than what we got previously, but still, you are kind of stuck, are you not? Taking the derivative of this guy, showing that it's always positive or something like that. Probably what we should be doing. So let's take the derivative of this guy instead. So you're gonna have 6u power 5 plus 30u squared minus 5u. Oh, it's minus 10u, sorry. Minus 10u and minus 11. So is this always positive? That's the question. I don't know. You got 5 over there. Interesting. Starting to think of something. Yeah. So is this always bigger than 0? That's the same thing as saying is u power 5 plus 5 u squared minus 10 upon 6, which is basically like 5 upon 3 u minus 11 upon 6 always bigger than 0. you are getting, yeah, you can see what I'm trying to do, right? Wait, okay, that's not going to work because unfortunately it's not u power 4, it's u squared. So, that doesn't work out. Wait, okay, it's not bigger. Okay, that's not the thing that we want to do. It's not bigger than 0 or anything. We want to set this equal to 0 and figure out the roots. This is getting too long, isn't it? Right, just for this kind of thing, you have to do all of that. It's not efficient. Ah. The other questions. Oh god, what is this? Now you got trigonometry and polynomials. God, believe this is happening. Okay, how do we do this thing? 6u power 5 plus 30u squared minus 10u minus 11 is equal to 0. Come on, think about it. Is there really no other way? Oh god. How do you even prove that this, like the values that you will get from there, those has, like those are the minimum values, right? Okay, and it will have a minimum because it's going to infinity on this side and infinity on that side, and it's finite in between, right? So it must have a minimum value, of course. But where do we get the thing? Does this, like, okay, maybe this thing is ever increasing and it only has one real solution, something like that. That would simplify everything. The derivative of this guy is 30u power 5 plus 60u minus 10, right? Sorry, u power 4. Is this always positive? What am I even trying to do with this? That's like the same, it's like saying, is this thing, or okay, whatever. We'll just say u power 4 plus 2u minus, it's like 10 upon, okay, that's 1/3 actually. Is this always positive? That's the question, right? Well, no, it's not. At 0, you can see it's negative, and okay, this doesn't work out. Oh god. Right, it's not ever increasing. It doesn't have a single minimum value. We will have to figure out all the minimum values and then actually do the thing. And anybody else think it's just a waste of time doing this? Well, I'm thinking of that it's a waste of time doing this. How do we go ahead? Do we really have to do this thing? That means 11 is a good number because it's just a prime. But then you got 6 over here, which doesn't make anything happen. And then you got 5th power. Not helping. It's not helping. Even though now it's much simpler, it's still not helping us. How do we proceed? Just guessing solutions, not the good idea. Okay, try 1, try -1. Something might work. Okay, 1 doesn't work because like 31, that's 20, 26 minus 11 doesn't work out. -1. Who am I kidding? Nothing's gonna work out. Try 11. Yeah, no. I don't like doing that. Okay, you got 6 over this, so you can actually try 1/3 or something like that. There's no way we are going to ever do this thing. Okay, at 1 it's positive, at 0 it's negative, so a fraction, that could be a root. And what could be a rational root for this thing? It could be 1 upon, right, okay, 11 upon something won't work. So 1/2, 1/3, 1/6, those things, right? What if we try 1/2? Let's try 1/2. So you're gonna have 6 plus 30 times 2, and that's like 60, and then minus this times 4 minus 40 minus 88. Doesn't work out. Okay, what about 3? So 1/3. No, it will be like 6 plus 30 times 3. You get the idea, right? Oh wait, okay, it's not that, it's u power, okay, that was not correct. What I did was not correct. And plus 2 power 5, like a 2 cube over this, like 8 times 3 is just a 240 minus 10 times of 2 power 4, I guess, because sure, so minus 160 or something, and then minus 11 times what? 2 power 5, 32. It's gonna be just minus 352 or something like that. Nope, won't work. Nothing will work like this. That's 6 over there. You have to utilize that somehow. These are like, okay, these are multiples of, oh yeah, sure, these are multiples of that. So those should actually come up with, so right, you just got like 6 minus 11, whatever, x power 5, okay, not x power 5. It's either 2 power 5 or it's 3 power 5. Like this should be a multiple of 5 basically, right? That's like saying 1 minus of 2 power 5 or 3 power 5. That was a multiple of 5. Okay, that's 32, that's 2, so it's negative 1. That doesn't work out. Otherwise you got 3 power 5, which is, it's like negative 2 power 5, I would say. So negative 2 power 5, negative 32, which, and the negative is positive, so 1 plus 32, which still doesn't work out. Oh god, these won't work. So there's no rational root. Oh, it's just too much. I can't handle this. How do you do this without actually going into the full calculation? Show that this has no reals. How? How do I show this thing if I can't even figure out the minimum values? I tried everything. You even tried forming a perfect square. Nothing works. Should I just give up on this thing? Maybe I should. Just, 7th is weird. That's all I'd say. 7th is weird. We don't know how to do it yet. 8. Construct a polynomial equation of the least degree with rational coefficients. One of whose roots is sine 10 degree. Okay. Rational coefficients. Hey, so there was something about cosine polynomials that I did, right? Okay, think what was the thing? So it was like, okay, the product of x minus 2 cosine of 2 pi upon n plus, no, not n, 2n plus 1, right? Yeah, that was the thing, times r. So this product from r is equal to 1 till n, right? So not 0, but actually 1. That's where it will start, right? This thing is what we'll call as Sn. That is actually just 1 plus t1 all the way till tn, where, right, you can actually figure out the t1 t. Okay, we can figure that out actually. It's not that bad. And in this case, you are dealing with sine 10 degrees, which is like cosine of 80 degrees, which is cosine of 20 degrees is what? It is pi upon 9, right? Okay, so it's like 4 times of that. So 4 pi upon 9. Okay. It's like 2 times of 2 pi upon, so 9 is what? It is 2 times of 4 plus 1, right? So you know what would be the thing? You just have to figure out what S4 is, right? That will be a polynomial that has, and you want the least degree. Oh god, that's weird. I mean, look, okay, all of these are just irrational values, and then the multiplication of the, oh god, you got the 4th thing. Oh no, this is very weird. So r equal to 1 to n, you will have 1, 2, 3, 4 at least. So it will be of the 4th degree. Damn, that's not nice. The 4th degree. But what? How? How can I even deal with that? 4th degree, huh? Not helping, not helping. But at least 4th degree is better than, something like the 6th degree or whatever. That's what we would have got using usual identities. So yeah, the 4th degree is definitely much better. Still, that's weird. Can't we just go to something even better? Like, what if it's just a radical and stuff? Oh god. Yeah, don't get your hopes up. I don't think it's going to work like that. And then you got sine 20 degrees and whatnot. So you'll have to generalize these. And yeah, I knew this. So cosine 10 degrees, cosine 20 degrees. This method is good, but is this the minimal polynomial? I have no idea. Is this the minimal polynomial? Instead of 10 degrees, cosine of 20 degrees and pi. How do you figure out? Actually, this might only be a cubic because yeah, 3c cube minus 3c is equal to 1. Yeah, actually, that's like cosine of 30 degrees, and that's square root stuff. Oh, that was a nice. Hey, okay, this thing is actually a cubic because one of these guys, so you got 4 pi upon 9, right? So r, it's gonna be like, you got 3 pi upon 9 over there, so it's just like pi upon 3. So cosine of pi upon 3 is an integer. Sorry, 2 cosine of pi, that's an integer and stuff. So that somehow does work out. And that's why cubic, right? Even using just normal identities, you will still get a cubic. That's nice. And okay, that's awesome, but you know, something else. So I get how you can do this thing for sine 10 degrees, and cosine 10 degrees is like harder. It's harder, sure. Come on, think. It's supposed to be having these guys. You will have a 4th degree. You can reduce that to a 3rd degree. I get it, but okay. What for like general methods? So general method for this thing. How will you do it? Yeah, you got like some is this always going to be a polynomial? No, some of these will be rational linear factors, which means that you can get those out. But other than those few numbers, how are you going to do this thing? Yeah, that's complicated. How am I going to do this thing? How do you find the least degree polynomial doing? Not helpful. Not helpful, definitely. You could always try factoring out some stuff. Oh, come on. So, okay. Some other way, because we want the least degree polynomial, not just a polynomial. You can figure out a polynomial easily, but then a least degree polynomial. That's a harder question. How do you make sure it's the least degree? Okay, for the first guy, it's actually much easier than the next few questions because it's just a cubic equation. We know it's a cubic equation. Yeah. So like, let's just say x is equal to sine of 10 degrees, then sine of 30 degrees, which is equal to 1 upon 2. That's just equal to what? It's equal to 3s minus 4s cube, right? Yeah, okay. For example, right, okay, sine of 3x is equal to sine of 3 sine of x minus 4 sine cube. For example, you got x is equal to pi upon 2, so sine of 3 pi upon 2 negative 1 is equal to 3 minus 4. Works, right? Okay. And right, so there we go, which is equal to 3x minus 4x cube. And that's equal to 1 upon 2, right? So 1 is just equal to 6x minus 8x cube, which means 8x cube minus 6x minus 1 equal to 0, right? This would be the thing. And what's the derivative of that? It's like 24x squared minus 6, which okay, it's not always positive, unfortunately. Okay, so some other way of figuring out the real root of this. There's one real root, I get it. And what about other two roots? Those are the roots that that satisfy this kind of equation, right? So 1 upon 2 is done by some other stuff as well. Okay, that's interesting. The least degree polynomial. Till now, I only knew about a polynomial. I didn't even think about what the least degree polynomial would be. Now I have to think about it. This has some weird questions that like, how did they even think that this providing this many of information is going to help us solve these kind of equations? Sorry, these kind of questions. Yeah, doesn't make sense. Well, whatever, that is the thing. So it satisfies this equation. And probably that's the least degree equation as well. Can you figure out the roots of this thing? Maybe not. Let's replace, okay, first of all, let's replace x by 1 upon x or whatever. So this will just be, okay, it's like u cubed. So x is replaced by negative 1 upon u. So just gonna get u cubed and actually no, you know what? No. not by negative 1 upon u, just replace by 1 upon u and then multiply the whole equation by negative. So u cube plus 6u squared minus 8 is equal to 0. Okay, now 8, right, does this have any rational roots? It's like a quadratic times u minus. So what if it has a quadratic polynomial that is not that's like irreducible but also has rational coefficients? Oh god. Even the thought of that is terrifying. How do you even figure that out? Like, can you get rid of that thing? You can't, unfortunately, because you cannot figure out the polynomial by itself. So, that was a nice. Come on, think about it. What can you do to get it done? Some other way of factoring this out, right? So I'm thinking of, okay, you got u minus alpha times. Oh god, no. This is weird. A quadratic is indivisible. That okay, that's gonna be having a rational root in front of it, right? So if you do think of it as having a factor as okay, a quadratic that is not reducible but it has rational roots, and then a linear factor. That linear factor must have its root as a rational root. Yeah, and that would mean right. Okay, so it has at least one rational root. Hey, what about this is getting very weird. The quadratic being okay, that having rational coefficients, that's only guaranteed when the first guy actually has a rational root. If it doesn't, the first root was irrational, then this is an irrational polynomial. It cannot have both of its root being irrational, but it can have one of its root being irrational and one being rational. Wait, okay. Sorry, both of roots cannot be rational, but they can be both at the same time irrational, right? Yeah, that's a problem because that would just mean, oh god, it would not have even a single rational root, which is a good thing. So, what am I doing? Oh god, right? If it was reducible, then the next degree you would go to is of course a quadratic, and we just proved that that cannot happen because then the other guy would just have a rational root. And does this actually have a rational root? That's the question. So let's check some stuff out. What about x equal to 1? It's gonna be like, okay, 1 plus, just take a derivative. No. Not gonna help us if we just take a derivative. Okay, just, start putting in values. 1 plus 6 minus 8, that is not 0. Okay, let's start putting 2. And also to the negative 1. So 1 minus 6 minus 8 doesn't work, as you can see. Put 2 in there. So you got 2 cubed with 8 plus, okay, you know what? Take that 4 out everywhere. So you're gonna have 2, that 4 is out. U squared, 2 squared is out. It's plus 6 minus 2, right? Not 0. What about the negative version? So, the negative version shouldn't be like this thing. It should be like this, actually. Yeah, but it's still the same story. So, not helping. Right. The other guy just has like a negative 2 plus 6 minus 2. That doesn't help at all. What about 4? Oh, it's not going to help us if we keep on going like that. You got 16. So take that 4 out. 16. And then you got that 4 is out. 6 times 4 is 24 minus 8. Doesn't help. What about the negative ones? So negative 16 plus. Oh shit. This helps. It has a rational root, which is. Oh wait, that is not enough. So actually a quadratic would be the better thing to do, right? But how? How could this be ever a quadratic? Because can it actually be represented in a radical format? No, how could it be represented in a radical format? Oh, this going nuts with it. So u equal to negative 4 actually works because you got negative 4 cubed, that's going to be negative 64. Plus 6 times of what? 16, which is 96, and then minus 8. Oh, okay, actually you have to get rid of that stuff. So it's minus 2. Yeah, okay, even that doesn't work. Of course, how could it work? That would be very weird. Okay, and let's try out 8. Positive 8, not gonna work. Negative 8, not gonna work. Yeah, negative 8 is got like negative 8 squared or negative 8 squared plus 6 times of 8, and that's negative 1. Doesn't work, as you can see, because that's like 8 times of negative 8 plus 6 is just negative 2. So negative 16 minus 1, negative, not 0. There we go. So that's the equation. Sure. That is the equation. The minimum degree equation. Okay, ninth. Consider the polynomial equation of least degree with rational coefficients, one of whose roots is sine 20 degrees. Okay. So 3 times of that would just be 60 degrees, and sine 60 degrees is a horrible thing. Okay, that doesn't help. Something else in that case. Sine 10 degrees, you're saying. That's like 2 sine of 10 degrees. And oh god, no, not helping. Or you could think of the cosine of 80 degrees, but I doubt that's going to help us. 10 degrees, oh god, think. Cosine of 80 degrees, right? That 4-degree equation you got, right? 3 of them were irrational and interesting. So you got like cosine of 10 degrees. So sorry, cosine of what? 80 degrees first, then you got cosine of 80 minus 2 is, so 90 minus 2, that's 70 degrees, and so on. Well, 10 degrees is 90 degrees, like pi upon 2 upon 9, right? That is, yeah, yes, that works out. So that was weird. 70 degrees like 7 pi upon 18 doesn't help, because that's not an odd number in the denominator. We only know some stuff about the odd number values, right? This is an even number, and we don't know how to do this thing. Oh god. And all of these guys also like have similar stuff going on. So, you know, sort of 10 degree, 30 degree. Let's figure out a polynomial that has all of these guys. So we got x minus cosine of 10 degrees and then all that stuff, right? Yeah. This, right. So what kind of, you know, equation would all of these satisfy? These are the form cosine of 10 degrees and stuff. Well, hey, I know a way to do this thing, although it could be really messed up, but who knows, it might actually work. So cosine of 10 degrees, yeah, I mean, that was the way actually that I got to that polynomial method that I told you earlier, but this is more general because it's gonna have 10 terms. Oh god, no, but a 10-degree polynomial is just too much, you know. Yep, not gonna help us. Like as you saw, this is actually just having a 3-degree polynomial. That was the meaning of polynomial. And similarly, you just want least degree, not some polynomial that has all of these. Okay, that won't help actually, because that will just give us a polynomial, not the polynomial. So no, we don't want to be doing that. Okay, something else. Something else that we can do with it. Sine 20 degrees. But sine 20 degrees plus sine 10 degrees. Yeah, that's interesting. Okay. No, but like we just want polynomial things. Okay, not gonna help us. Okay, think about it. Sine square can be represented using cosine of 40 degrees, right? Sine cube can be represented as a linear combination of something that involves. Yeah, okay, that's interesting. Different powers of these guys, right? So sine 10 degrees, sine 20 degrees, sine 30 degrees, and so on, right? Okay, actually sine 20. So like powers of those. Thing is, you can, okay, if you assume x is equal to sine 20 degrees, then you can represent sine of 40 degrees and sine of 60 degrees using these kind of, you know, polynomials, right? So this is actually, oh no, it's not doable. It's not doable. It's gonna have cosine values involved in it, and that's horrible. We don't want to be doing that, right? But sine 60 degrees, at least that's doable, right? Okay, that can be done. Uh, complex numbers, right? Of course, e power I 60 degrees minus e power I negative 60 degrees, and then upon 2, and you have to write that in this format. Some kind of, how is this going to help us? Okay, you can use a cubic representation to get sine 60 degrees. I get it, but that's a radical. That's just not good. So let's go 3 upon 2 or something like that. That would be a 6-degree polynomial. There's no way that we can do that. Okay, what else can you do? It's like, okay, this thing times 3, what about this time 5? So sine of 100 degree. Most likely that can also be represented using a polynomial function of sine 20 degrees. So sine of 5x, although I don't have a formula for that right now, but maybe it can be represented. It's like sine of 3x plus cosine of 2x and some stuff like that. So maybe, right? Well, it's cubed over there. So I could take that 3 out. And actually, yeah, I guess sine of 5x is something that can be done. Some kind of combination of these guys, right? It's like, okay, 20 times 1, then 3, then 5. Interesting. I'll keep on going like that. What if you just, add these up? These are like the the imaginary parts of e power I 20 degree. And what is 20 degree? It's like 20 degree is pi upon 9, right? So 180 upon 9. That's, yeah, so pi upon 9. Then you got plus e power I 3 pi upon 9, and then plus e power I 5 pi upon 9. All of these have this unique property that the ninth power of this number that's going to be equal to negative 1, right? And then we should just keep on going. E power I 7 pi upon 9. Okay, that's just too much because that's a 7 degree. That's going to be 7 degree. We don't want that. We don't want a 7 degree equation. The 6 degree would be better thing to do, of course. So that is the meaning. Yeah, this is not going to work. This is just too much. Okay. You want the imaginary stuff going on over there. What is this? Okay, 7 pi upon 9, and then got plus e power. And okay, that's 9 pi upon 9, right? We can write this as e power I 0 upon 9. So now we just want the odd numbers, not. Yeah, like 9 pi upon 9 would work actually, just e power I pi. Yeah, well, whatever. And yeah, and then it's like, okay, that's in this quadrant, and we're gonna go on this quadrant as well. That's just too much. But we just want the y coordinate stuff. So these vectors are going in this time. Yeah, okay, that y coordinate sum would not be 0, unfortunately. That's no way of doing it. That's no way of doing it. You know that. Okay, don't do it like this. Sine of 100 degrees, it could be represented as, sine of 180 minus. Okay, no, just skip all that. I don't think that's a good idea to do it. Okay, so sine 60 degrees, that's just for 3 upon 2, that can be represented using, yeah, okay, 3s minus 4s cubed, whatever. So 3x minus 4x cubed, right? So it at least satisfies this equation. Okay, so like 8x cubed minus 6x plus square root 3 is equal to 0. It satisfies this equation. And now we have to figure out, okay, this is very weird. So we know a 6th degree equation this satisfies, which has rational roots, but 6th degree, can't we get something small? I doubt I cannot. So what values does this satisfy? Right? What value satisfy this equation? Anything that has the same sign value, right? So sine 120 degrees, right? Okay, 1/3 of that guy. So the sine 20 degrees work, and what else can work? Sine of 40 degree, right? Okay, that also satisfies this equation. And since this, okay, Yeah, multiply the conjugate of that thing and whatever. So like 8x cubed minus 6x power of 2 is equal to 3, right? This equation is satisfied by not just these, but actually negative sign of 20 degree and negative sign of 40 degree as well. Right? All of these values are just irrational. Oh, this is not looking nice. Okay. All these values are irrational. Some combination of these guys would be rational. That's what you're thinking. You got a 6-degree equation, right? Because that has a cube over there. Wait, if it's a cube, then just keep on going. Okay, what about sine of 60 degrees? That will also work, right? Because 3 times 60 is like 180. Okay, that won't work. Something else that gives the same value. No, 120 degree plus. God, I'm really out of my brain juice. So 360 degree plus something, right? Okay. You could also have negative values, but let's not use those. Let's not use those. Right? Something that has curved here upon 2. That would work, that would work. 360 degrees plus 60 degrees, right? That's gonna be just 420 degrees, half of that. That's 210 degrees. That will also work. Sine of 210 degrees, right? Which is like, okay, negative sine of it's 180 plus 30. What? No. How could that? What is this? Why is this happening? Because you want the one third of that, not 1/2 of that. So you got 60 degrees plus 360 degrees. We want the third of that, which is just 120 degrees plus 20 degrees, which is 40. So 140 degree, right? Yeah, which is like 180 minus 40, but that's already over here. So it's actually the same value. It really is the same value, huh? Understandable. So the values that actually satisfy this equation are these values, right? This and that. But that's a cubic. Then you got, okay, 2 irrational roots, and this is very weird. It's a cubic. It should have 3 roots. The third cannot be complex number. It has to be a real number. But what is the third root? Help me. That won't work. So what about 120 degree plus? Okay, that thing upon here is going to be just 120 degree plus oh god, 120 degree plus 40 degree, which is 160 degrees. So 180 minus that is 120 degree. Sine of that is the same thing as that. That doesn't help us at all. Yeah, it doesn't help. Oh god. This one, like sine of 3x is equal to sine of 60 degrees. There's 2 ways that this can happen. 3x could just be 60 degree plus 2n pi. So plus 360 degree times n, or you could just have 3x is equal to 120 degree plus 360n. So x could just be 20 degree plus you got 120 degree n, and x could just be right. It's like 120 degree n. It's weird, and that's gonna be what? What am I doing? Okay, 120 degree n. So we already got these 2 values. What about this plus one? That's like 140 degree, but it has the same sign value. So how does it even help? It doesn't. Okay, then 2 times of that. So like 240 plus 20. That's like 260. Maybe that's gonna help us. So 260 degrees. Then oh hey, actually that's negative or something. Okay, that's actually 180 plus 80. So it's negative sine of 80 degrees, right? That's what this thing is. Huh, interesting. So negative sine of 80 degrees somehow works out. Very interesting. And then similarly, you could just do 2 times of that. So like 240 plus 40 is 280, right? So 280 is like 360 minus 80. So once again, negative sine of 80 degrees, right? Both are the same stuff. Okay, makes sense. Yeah, wow. So you got the third value as well, which is negative sine of 80 degrees. So the roots are this thing. Makes sense. Yeah, right. That explains why the product is actually just okay. Okay, awesome. So any quadratic factor of that thing, it will not give us. Okay, I get the thing, and then okay, negative versions of that will satisfy the grand equation we'll get. So we'll just have sine of 20 degrees, sine of 40 degrees, sine of negative sine of 80 degrees. Yeah. So the actual values that you will get is like these values, right? Negative sine of 40 degree and then negative sine of 80 degrees or whatever. Sure. So is there any other combination using these that actually gives you something that's come on. I don't think that can happen. Okay, I need to stop because this is getting very complicated. Yeah, I guess we should stop now. So let's see you in the next video.